Hello everyone, Quintickle here with another video. Today we're going to talk about one of my favorite numbers, and that is pi. Now, despite what other YouTubers might tell you, VR, pi is actually quite awesome, and you can do lots of things with it. You have lots of formulas for the area of the triangle, for the area of the circle with it, for the area of the sphere, the volume of the sphere, the cone, the cylinder, and all that. But what us as humans have always been wondering is, how much is pi? And this will be the question of the day. So, the way that Pythagoras calculated it, is he basically took a polygon, lots of sides, I'm going to draw an octagon here, 8 sides, and he said, let this diagonal be 1. And when you draw a circle around it, I'm not all that good of a drawer, but just imagine that's a circle. A circle. I'm also going to do that with the hexagon as well. Just keep that in mind. So the diameter of the circle is 1, and since the formula for the circumference is 2 pi r, and 2r is equal to the diameter, it means that the circumference is dr, and d is equal to 1, which means that the circumference is equal to pi. So basically you take lots and lots of sides that have lots of sides, lots of polygons that have lots of sides, and the thing is that if you draw things that are closer and closer to the circle, and you calculate their perimeter, and because you could contain this inside that figure, it means that pi is slightly bigger than that. So for example, if I don't know, I'm going to draw a circle. Perfect. I'm going to put a square inside of it. And I'm going to prove to you when we have, and you could split it, and its diagonal is 1. So the way to solve this is actually quite easy. We know that the diagonal is equal to the side multiplied by the square root of 2 in a square, obviously. We're talking about regular polygons that have all their sides equal, which means that the diameter is equal to, the diagonal is equal to, I already wrote that, which means that 1 is equal to s multiplied by square root of 2, which means that s is equal to the square root of 2 all over 2. And that's one side. And to find its perimeter, multiplied by 4s, so the perimeter gets 2 square root 2, which means that pi is bigger than the 2 multiplied by the square root of 2. And if I start my calculator right now, and hopefully I know how to use it this time, if we get 2 multiplied by the square root of 2, we get 1.41. So pi is bigger than 1.41. Now that's not all that accurate, so we're going to also do it with a hexagon. To draw a circle, draw a little hexagon inside of it. There you go. Perfect. And its diagonal is 1. Now, the thing that you can do here is the way that we're going to solve our problem over here, is basically you just split this in triangles, and you find out everything you need. So I'm just going to draw all of its diagonals. Remember, they're all 1. Oh, I drew this very nicely. And they all find in this point. And this is 0.5, 0.5, and they're all 0.5. So, and also because since these are all equal these are all equal angles, it means that this is an equilateral triangle with the side of 0.5, which means that the side is 0.5. And that means that the perimeter of this hexagon is 0.5. I'm going to do commas, you know what? Multiplied by 6 is equal to 3, which means that pi is bigger than 3. Now, Pythagoras didn't have, he might have, but I have no idea if he did. Pythagoras didn't have all those fancy things that we have now, you know, sine, cosine, tangent, cotangent, and he basically just drew them manually and tried to solve for them, just drawing them and putting all the diagonals and solving them, but we can do better than that. So basically our problem is having a triangle, an isosceles triangle, having both of its sides equal to 0.5, and knowing this angle, how much is this? This is also 0.5. So this is the problem that we're going to solve today. This angle is 360 divided by x, where x is the number of sides. So for example, if we take, I don't know, 1,000 sides, draw like a regular polygon with 1,000 sides, then x is going to be that number of sides. So knowing that, we have to try and calculate how much this is. And what I first thought, well, that doesn't seem very complicated, but you'll see it gets complicated. It gets complicated. So what I did is, I took A, this is B, and this is C. I'm going to delete the question mark because we need for later. Good. And I took the perpendicular from A to BC, this is perpendicular, and named it H. Good. Now, how much is this angle? That angle, my friend, is 180 minus, so the sum of all these, 180 minus 360 over x, which is this angle, this entire angle, all over 2. But we can do one better. We can find it even closer. And that is going to be equal to, I'm going to go into the AHB triangle, and I'm going to go ahead and tell you that the B angle is equal to 190 minus 180 over x. And this is how much this angle over here is. Good, and that is equal to 90 over x minus 2. Okay, obviously all over x. So how much is BH? Is equal to question mark. Well, that is simple. BH is equal to the sine of BAH, AH, multiplied by BH. Oh wait, that gives us, well, the sine of BAH, I'm actually going to do this a bit more openly because we're trying to get this closer. I tried to make this as easy as possible for you to understand. So the sine of BAH is BH all over AB. So the sine of Bach, and I'm going to call it that, the sine of Bach is equal to 2BH. Remember, AB is 0.5, and dividing something by 0.5 is equal to is like multiplying it by 2. Perfect. So the sine of Bach is equal to 2BH, which means that BH is equal to, and also BH, I did this with the sine because it's easier, but I'm also going to do it with the cosine. And it's also equal to cos of BH. Oh, the cos of ABH. H is equal to BH over AB. Good. So that's also equal to 2BH. BH. And we've already proven that this angle is 90 over x minus 2 all over x. Perfect. But we can actually do something better. We can actually find these angles in a different manner. So basically, we know that this angle, this plus this is 180. So ABC, I'm going to calculate by this formula. And it's 180x. Yeah, it fits. Okay, so this is what we get. This. Okay, so we take the cosine, the cos of ABH, and we know that that's equal to 2HB. So we just divide it by 2, so we have cosine of ABH. And it's all going to be divided by 2. Perfect. And that's equal to the cosine of 180x minus 2 over x. That's perfect so far. Great. So let's see what we know. So it's the cosine of 180x minus 2 over x. 180x minus 2 all over x. Right? Am I right? Please tell me I'm right. And I was right. Oh, but it's 100 and... what? 90. That's 90. What have I done? This is 90. Oh, okay. Now it's going to be... wait, I have to get back to... yeah, so it's 90 and that. Now, you can also get this size. Now, some calculations later, you're going to get that size. I'm not going to explain all of it because it's a bit more complicated. But the point is that in this triangle, in a triangle where you have both of your sides equal to 0.5, and this angle is 360 over x, you can actually figure out that this size, which is x is equal to the sine of 360 over x, all divided by 2 multiplied by the cosine of 180 all over x. So x prime, fine, and x being the number of sides. So basically, a formula for calculating pi would be pi is approximately equal of x multiplied by the sine of 360 over x over 2 multiplied by the cosine of 180 over x. Let's make this line a bit longer. And the higher x gets, the closer you get to pi. So basically, in a bit more complicated terms, to those of you who are a little smarter or have done some more complex maths, basically a limit of x going to infinity of x multiplied by the sine of 360 over x all over 2 multiplied by the cosine of 180 over x is equal to pi. This is all I've got for you about pi. It's a way of calculating it, and I'm going to use a calculator right now in order to prove to you that this method works. Again, hopefully I can use it this time. And I've also learned that the C button clears everything. Okay, so we're going to find out how much the sin of 360 divided by 1000. So it's equal to 0.360. And we get this number as our result. In degrees, obviously. Okay. And we take this number and we divide it by a parenthesis. Do we have yes, we do have parentheses. 2 multiplied by 180 divided by 1000. No, not 1000, just 100. Did we put 100 or 1000? I think we put 1000. And we close the parenthesis. 2 multiplied by that. Oh wait, it's bit back. The sine. No, the cosine. No! God damn it! Okay, yes, perfect. Divided by a parenthesis of 2 multiplied by another parenthesis 180 divided by x by 1000 in our case, closing the parenthesis, putting a cosine, and closing the parenthesis. and wait, what? S of 0 sine 2 multiplied by the and everything multiplied by 1,000. I think I got something wrong. Did I put equal numbers? Yeah, it should have worked. Multiplied by 1,000. Oh, and look what we get. 3.14158. 3.14158. And the actual, and 7. And the actual decimals of pi are 3.14159. So I think this formula for a number as low as 1,000, I think the formula did pretty well with a precision of 4 digits and if approximating 5 digits. Now this is all I've got for today for you. If you enjoyed this video, be sure to leave a like, and if you really enjoyed it, make sure you subscribe. Maybe even share this with your friends if anyone's interested. And as always, thanks for watching. Quintickle out.